Everyone, today we will study about the topic of what is the reference architecture for IoT, how the IoT system is built, what are the various components involved. Today we will study about that. So IoT devices are almost increasing at a very humongous rate, and there will be almost 50 billion devices connected all around within the network with the help of internet by 2020. So it's a huge number, and IoT will be in great demand, and it will be the basic necessity of everyone to use these devices so that they can further create their life easier, smoother, and more flexible. Now, for studying the what is the architecture for IoT, first we will do some basic done uh, know about some basics. Now, what is physical computing? IoT devices implementation nothing but it is the physical computing only. It is a in physical computing we have to build interactive physical systems with help of software and hardware that can sense and respond to our analog world. So it's nothing but with help of software and hardware we have to sense something and respond to the analog world. It is our physical computing, and it is also our implementation of IoT devices architecture for IoT. So in diagram also you can see interactive system and this real world. Real interactive system senses the information, and in turn actuators interact with the real world. So this is the whole process of physical computing described here. So what is Internet of Things? Internet of Things, IoT or IoE, Internet of Everything. It is these are both the same terms. Soon IoT will be converted to IoE, Internet of Everything. Everything is get connected with help of internet, and everything almost by 2025 all things will be connected, and there will be a real-time sharing of data of every devices. So it was a term coined by Kevin Ashton in 1999. It refers to uniquely identifiable objects and their virtual representation in an internet-like structure. So what consists of Internet of Things? Internet of Things consists of wireless sensor networks. Internet wireless sensor network having power to sense any parameter according to our demand, and these also are internet connected variables, low power embedded systems, RIoTs, RFID enabled tracking that is used to code some, they scan some barcode scanner type you have seen in the while purchasing the product, the barcode is scanned and beside and behind the product. So use of mobile phones to interact with the real world. Devices that connect through Bluetooth enabled mobile phones through the internet, smart homes, connected cars, etc. Are these are all are consists of these Internet of Things consist of all these things, and these are examples, and these are the components used for building up the Internet of Things as a whole. There are some concerns. There are some core concerns related to IoT. First one is security. It's the all the devices are connected to the internet, and they are sharing and exchanging data. So there are possibility of data thefts, stealing. So data is at stake. It's a severe security concern. Second one is power consumption or battery life. The power consumption of and battery life of devices, it should be optimized and should be maximized. And third one is software updates. The updates or the patches of different softwares should be available on a real-time basis because of the glitches come at a come time by time on and they can be exploited by the hackers also. So the patches and updates should be released regularly, and there should be recovery from network failures and other failures regularly, and connectivity and communication issues or concerns should be resolved on a real time basis. And their device management should be there, proper device management, so as a different device connected should be managed with the help of central command center. Data collection, analysis, and extraction should be there. The whole procedure should be followed. Standardization should be there. Second, last one is scalability. Scalability. This is a massive scaling. We will be using. We are having devices growing at a very rapid rate. So they should be scalable. Massive scaling should be adjusted, and there should be no issue of in scalability. So, what are the device types that are used to implement these devices? First one is 8-bit system on chip controller. This is Arduino kit. You must have listened to it, and you was known to it. Is a no no operating system, and the second one is system based on Atheros or ARM processors like Arduino Uno. And the third device type for implementing a physical computing platform is Raspberry Pi. It is a Linux-based platform. This is the example of Arduino kit SoC chip. It is having the sensors, having a reset button, having capacitor, resistance. We can program this with the help of Arduino IDE. We can code them with the help of Python or any language or C with the help of Arduino IDE. This was I was saying that on this Arduino IDE we can implement the code. We can put the sensors to run. We can program the sensors. We can programming the various chip as a whole, and we can program according to our need on this Arduino IDE. This in a slide is a Raspberry Pi. This is also a SoC, or this is a chip having different sensors, resistance, or to which we can program all the functionality of any device which we want to monitor or program with the help of Raspberry Pi. So for communication purpose, to connect these devices with the help of internet, there are many types of technology used. We will discuss some of them. First one is direct Ethernet. It is Wi-Fi or 3G. It is having long range when the distance is very large among the devices. This protocol comes into the picture. Second one is Bluetooth Low Energy BLE4 or Bluetooth 5. It is a low range device. Like it is same as in our mobiles. It is get connected when we move away from the device for 1 meter, 2 meter. It is a very short range device. RFID, near field communication. It is also a very low range device. It's almost uh, less than few meters. So it's a very low range device. Whereas when this communication protocol is used when the device is very short range. Another communication protocol mostly commonly used is Zigbee or other mesh radio networks which are having medium range when the distance is not so short and not so long. We use these protocols for communication. So in this slide we will have you take a look at the how the communication takes place. In first half of the slide there is server side cloud having different servers having there, and we have the Arduino devices in the beginning, different devices, Raspberry Pi or our mobile Arduino. These are get connected to the server side cloud with the help of Ethernet or Wi-Fi by following TCP and UDP protocols for transferring the data. And in the next one we are having the server side cloud and the gateways, NFC These are the devices like our smart cars, mobiles, and Arduino. These are all get connect to the server-side cloud with the help of gateways, with the help of our different protocols, NFC, Bluetooth, low energy, MQTT, Zigbee, etc. So these are all the structure for communicating our hardware devices with the help of these technologies. So there are various communication protocols used for the exchanging data information in the devices. First one is HTTP Hypertext Transfer Protocol, which is used to transfer data with the help of HTTP request and response commands. Second one is the MQTT protocol. MQ telemetry transport is the most commonly used protocol used in IoT devices. We will study about it in detail further. Third one is COAP, Constrained Application Protocol. It is also one of the communication protocol used in communicating through the devices connected. Now we will study about the MQTT protocol used for communication between different IoT devices. MQTT is the MQ telemetry transport protocol. M2M or it is an M2M or IoT connectivity protocol. Both in both models can be used. It is extremely lightweight sub-messaging transport protocol. It is extremely lightweight. It is very useful for connections with remote locations where a small code footprint is required or a network bandwidth is at a premium. It can be connected with that very remote locations. It is having very low latency, assured messaging over fragile networks, and efficient distribution to one or many receivers. It mainly focuses on minimizing the amounts of bytes flowing over the wire. It is having low power usage. It is have a high volume of low size messages. It is having a better efficiency at a high volume of low size messages. It provides a two-way communication channel. Zigbee is also a protocol used for communication between different devices so that they can exchange and share the data among themselves. This first one is, as you can see the diagram, the blue nodes stands for coordinator node, yellow one is the router, and this green one is the encoder. So first one is P2P, peer-to-peer. All the devices coordinators are connected to the end nodes. Green one are end nodes. And in star also we have a coordinator in between and all the end nodes are connected to it. The coordinator acts as a central server. In mesh, in mesh all the coordinate devices, routers and end nodes are connected with the help of, but there is a single coordinator node as you can see in the diagram. These are all used as a network topology according to our need which you want to use. So what do we need a reference architecture? What came up so that we needed a reference architecture for IoT? It's because IoT devices are inherently connected and we need a way to interact with them. So we need a reference architecture. There are billions of these devices. We need a scalable architecture that is highly available and allows disaster recovery. Management of devices should be there, automatic update should be there, remote management should be there. So we needed a reference architecture to work upon. Security is a concern issue. These devices collect sensitive data. If this data goes into the hands of the exploiters, it can cause huge loss to the owner of the data or the user. So we need a architecture that should be referenced or standardized by all the IT devices, ownership of data companies, etc. It also it provides a starting point for architects looking to gather create IoT solutions as well as strong basis for IoT application development. So all these are the demands which came up for a need of reference architecture to be built so that all things related to IoT devices are standardized and goes in a smooth and easy manner. Thank you, everyone.